So today we are going to start the series of lectures on hashing demystified. Hashing is a very important topic in all computer science and has lot of application in NoSQL database and file searching, information retrieval, and in many places. Okay, hashing is basically building block inside all softwares and systems. And most importantly, cryptography is heavily dependent on hashing. Okay, so in this series of lecture, first we will start from the set membership problem in order of 10. Previously, we have done a lot of searching techniques. We have learned a lot of searching techniques, linked list, binary search tree. The complexity of linked list is order of n. Complexity of binary search tree, if it is balanced, then it is order of log n. But balancing mechanism is very tedious. We have some more data structure like skip list, which provides us probabilistic guarantee of order of log n. But hashing is unique. It can give us order of one complexity, means we can have constant time search if we can handle it properly. If we choose the hash function and maintain the hash table wisely, we can easily achieve the order of one search. Okay. So what we are going to cover in this series, first we will cover the set membership problem. What is set membership problem? How we will solve that. Then we will directly come to the hashing techniques, which is very simple and easy. And inside that, two important thing is how to determine hash function, how to determine hash table. Okay. So there is obviously some concept of good or bad, good hashing or bad hashing. So we must learn there what is a good hashing, what is a bad hashing, how to measure hashing. Okay. That we will learn. So a measure is associated with this. Then we will go for collision resolution, chaining, which is a collision resolution technique, and we will see the load factor in chaining, and then we will see the some very interesting concept of table doubling and its complexity. Okay, if we use dynamic table, this concept is very much similar with dynamic array. We will learn these things, how to implement that in practical life. And we have the open addressing technique, which is quite old but still in use. And then we will see the major theory of hashing, how to make a good hashing. So what is perfect hashing and what is universal hashing, how many choices are there. These are basically used in cryptography. And we have a recent hashing technique which is almost perfect hashing, that is called cuckoo hashing, which gives us the collision free hashing. And there are more concepts like Bloom filter. Bloom filter is nowadays very popular tool in computer science, used in database, in network. Okay, so let's start with the hashing technique. First, we will start with the set membership problem. Okay, so let's start with set membership problem. What is set membership problem? Suppose we are given a set of elements, items. Let's say U1. I am writing elements, so using U1, E2, E3. You can write item also for the same things. Let's say there are n number of elements and inside a set, and there is a query element, let's say ex, and we have to say whether ex belongs to s or not. Okay, so query is given an arbitrary element ex, we have to say whether ex is present in s or ex is not present. Okay. And if present, we have to find out its value. So these elements are generally written in this format. Elements are basically key value pair. This key is used for creating the hash. So a simple idea of hash table is, suppose this is our set of element S, which contains all the elements E1, E2, En, and we have to create a data structure to find this element. So we have the data structure is yet another array data structure. Okay, it is contiguous location. There are array, there are heap, and there is hashing, hash table. These three are most popular data structure which use contiguous memory. Okay. All other data structure like linked list, binary search tree, they use pointer memory. So how we do these things? We have to choose a function from S to this. So unlike other function, this is as function is little bit different. So instead of writing fx, we write h of ex or ei. Okay, this is the hash function. What is the difference between any arbitrary function and hash function? Let's say the size of this table is m. So these are the indexes. This is m. Okay. The size of the table is m. So we can write m minus 1. Right? Okay. So size of the table is m, and we have n element to map. What should be the size of this m? Will it be m greater than n, m equal to n, or m less than n? What is the correct answer? If we set m less than n, then what will happen? We have n element to map in a table of size m, where m is smaller than n. Then we have the pigeonhole principle, which tells us that two element, at least two element, will be mapped in a same box. So there will be collision. Okay. So we are not going to accept these things. Ideally, we want something like this, m equal to n. That will be a very ideal situation. That there will be no wastage of memory, and developers always want this situation. But this is little bit difficult. So and very high probability of getting collision. So we go for this one. M greater than n, but not too much bigger. That is the ideal condition. N should be greater than n, but not very much bigger than. Okay. Now coming to this hash function, how this hash function is created. This hash function, domain of this function is the set of all elements. Okay. This is the domain. Every function has domain and range. The domain of this function h is the set of all elements, and the range of the function is between 0 to n. This is the bound. Okay, this restriction must be followed. The range of the function must be, it cannot be arbitrary. It must be between 0 to n minus 1 to become a hash function, qualify for a hash. So how many such functions exist? Okay, if we have two set A and B, A has the cardinality of n and B has the cardinality of m, how many functions we can draw from A to B? Okay, we can derive m to the power n number of functions here. How? Because every element can be mapped in any position. Okay, So this element U1 has the probability of choosing M option. Second element has the M option. Third element has the M option, and they are independently brought and assigned to the table. Okay. So if the function is assigning the element independently, then there will be m to the power n number of such functions. Okay. Now which function to choose? You choose any function. Not all functions are good. Some functions are very good. Some functions are not. So we will define some measure first before uh, doing the proper analysis. Okay, which one is good function, which one is not so good function. Okay, so what's more, this is the hash function. So how to get this range? Suppose there are many functions we can do. Let's say uh, I'm writing some function h of x equal to a into x to the power, let's say 7 plus b into x to the power, let's say 5 plus constant c, this mod p, and mod n. I have less place, so this is mod n. Okay, what is this p? P is a large number larger than m. Okay, this function can become a good function. Why? Because p must be prime. So we will see these things in later courses, and we will do a lot of analysis on the function. Okay, so this is all about set membership and basic hashing technique. Now we will come to in the next lecture. We will come to the collision and collision resolution method. Okay, that's all.